A pressure switch is the cheapest way to start and stop a pump or a compressor. No analog input card. No transmitter. No scaling math in the PLC. Just one small device that flips a contact the moment pressure crosses a line you set. It has been doing this job on the factory floor for decades, and it is still everywhere on well pumps, air compressors, hydraulic packs, and safety interlocks. So how does something this simple actually work? In this video, I will show you what a pressure switch is, how the Setpoint and Deadband stop it chattering, the difference from a transmitter, and how to wire it straight into a PLC. Let's start with the core idea. Quick note before we dig in. This is from PLC Simulator, where you can practice sensors, wiring, and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now back to the switch. Start with what it does. A pressure switch trips a contact at a pressure set point. That is the whole job. Pressure rises, the contact changes state. Pressure falls back, it changes back. Now, compare that to a pressure transmitter. A transmitter sends a continuous 4 to 20 milliamp signal, proportional to the whole pressure range. It tells you the exact value all the time. A switch does not. A switch tells you one thing only. Are we above the set point or below it? 1 bit. And for turning a pump on and off, 1 bit is all you need. It also costs a fraction of a transmitter plus an analog input card. That is why the switch refuses to die. Here is the part most people get wrong. A pressure switch does not trip and reset at the same pressure. It has 2 set points, a cut-in pressure where it turns on, and a separate, higher cut-out pressure where it turns off. The gap between them is the deadband, sometimes called the differential. And that gap is the whole point. Picture a pump sitting right at a single set point. The pressure jitters up and down across that line. With no gap, the pump would switch on and off dozens of times a second. That is chattering. It hammers the contactor and burns out the motor. The deadband fixes it. Pressure has to climb all the way to cut out before it stops, then fall all the way to cut in before it starts again. The system gets room to breathe. Now, the contact itself and what is inside. Mechanically, a pressure switch is usually a diaphragm or a piston pushing against a spring. Across the set point, the spring gives, and a little microswitch flips. Electronically, it is a pressure sensor feeding a comparator that does the same thing in silicon. Either way, you get a contact, and that contact is either normally open or normally closed. Normally open closes when the pressure condition is true. Normally closed opens when it is true. I cover normally open versus normally closed and digital input wiring in detail in the link sensors video. The rule that matters here: pick the one that fails safe for your job. For a low-pressure safety, normally closed is usually the right call. Finally, wiring it to a PLC. A pressure switch is a discrete device, so it lands on a digital input, exactly like a push button or a limit switch. One side goes to the supply. The other side goes to the input terminal. The PLC reads it as a simple on or off bit every scan. From there, the program does the rest. Pump control: start the pump on cut in, stop it on cut out. Compressor control: same idea on an air receiver. Or a low-pressure interlock that trips the machine the instant pressure drops out before something gets damaged. One cheap contact, one digital input, and the PLC has everything it needs. So here's what to walk away with. A pressure switch trips a contact at a set point. It gives you 1 bit, not a continuous value, and that is why it is cheaper than a transmitter for on-off control. The deadband, the gap between cut in and cut out, is what stops it chattering, and it wires to a plain digital input, like any other discrete device. Get that, and the pumps and compressors on the floor stop being a mystery. Now, go make it concrete. If you want to practice sensors and wiring hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.